Hello everyone, welcome to the next class. So in this class, we're going to continue executing some basic Linux commands, specifically Oracle Linux, in this case, but these are commands you find in all distributions, Linux. All right? So it's important for you as a database administrator, as an Oracle database administrator working on Linux to have an idea of how it works. It's good because in your daily routine, you have to use some of these basic commands, probably in your organization. The Linux architecture structure will be ready and you'll be taking care of the database part. The database, most likely, especially since you're working with Oracleize, a large corporate database, mainly with Oracle Enterprise, only large corporations use this database, even because of its cost. The Oracle Enterprise licensing cost is quite expensive compared to other databases. So you'll definitely be working within a team that's responsible for the Linux part itself. For example, when you need more disk capacity, you'll request this from the Linux team so they can provide greater storage capacity for your databases. What you need to keep track of is the amount of free bytes available on the volumes that have been mounted for your database. This is important. Usually in organizations, you'll also have some kind of tool that monitors this disk space. Things like Zabbix, Datadog, Splunk. There are several free and paid tools you can use to manage your environment. So here, still starting out, actually going back to the basic commands. It's interesting. If you have access to this kind of command, to run this command, with the ddfh command, you can check basically the amount of free space available in a directory where you know your databases, your PDBs are located. So it's a good idea to run this kind of command and keep an eye on it if you have access. But you'll definitely be getting percentage information about the amount of available space in a directory. Linux works with a file system. We saw a bit of this when we installed Linux, when it asked us for each directory which file system you were going to use. It already comes with a default, for example, X4, as we saw in the lesson where we installed Oracle. Linux works with different file systems, often even to store different types of files. There's X4, as we saw, but you can use and create other file systems. And these file systems are mounted on directories. So when you run that dh command, you can already see some file systems and where they have been mounted. So for example, this one here is a file system. The tmpfs, which was mounted on this directory. This file system was mounted here at the root, and likewise, the same goes for the other file systems. And in Linux, you have the flexibility to use different file systems and to mount these file systems in different directories. You can even, for example, have a file system, a file related, for instance, to a flash drive mounted in a specific directory. Do you remember that I told you in the last class that for Linux everything is a file? So we went to that dev directory and saw, for example, files related to disks, to CD-ROMs, they are files. So in Linux, a disk is a file, and for you to use that disk or a flash drive or a CD to read or write information on these devices, you need to link these devices and mount them. That is, when I say link, I mean mount these devices to some directory. And from the moment you have access to that directory, you have access to that device, right? So each type of device, it uses a file system that is related to the device type. It also relates to the file type you are going to store. So when we install Linux, we already create the directory structure. Remember, we create the root, the boot, the home, and Linux. It already comes with a default file system in that little window. If you forgot, go back there. And it already brings a default for us to use based on that directory, a file system that it thinks is appropriate. All right. If we were to add a new diskant, this is usually done by system teams who work with Linux. You would then simply link either a disk, or it could be a disk partition, an LVM partition, for example. You would then add that partition or disk to a directory. You would mount it to a directory. If that directory filled up, there's no more available space because the disk, for example, is full. You can easily add a new disk to this logical partition structure that Linux uses, and you could mount it to any other directory, or in that directory you're already working in, use this new volume that was added, right? So when you run this df-dh command, if you have permission, you can check some interesting information. For example, here on the left, the file system, the size of this file system, how much has already been used, how much is available, the percentage that is available, and where this file system has been mounted. It was mounted here on dev, it was mounted on boot, right? It was mounted on home. So imagine you working on your database and one of these directories has been mounted, or in a new directory based on one of these, and here you see that 99% has already been used. You're going to have a space issue, right? And then through some tool like Zabbix, this can be alerted. And then it's up to you, the Oracle DBA, if the Linux team isn't already aware of this issue, to alert them that you need more capacity to be made available. In this directory, which was mounted based on a file system, for example, the boot was mounted on dev SDA1. If you go to this directory here, you'll see this file inside, right? It's a file system that was mounted on this disk. You could expand the capacity of this file system, of this partition. using some commands, right? And as a result, you could make this new capacity available to this directory, or you could add a new disk, right? A logical partition, and then provide new capacity for this environment, for this directory. But this is handled by the infrastructure team. So I'll leave some concepts written here. If you still have any questions, advantages. And if, for example, we need to mount as a practical example, except the process is more complex than this. When you work with partition architecture, LVM, here's a simple example. Imagine a situation where you have a new disk that you added to your Linux, or maybe a flash drive that you plugged into your Linux, and you want to mount this flash drive to a directory you created. So you created the directory there, mkdir, right? And you want to mount this file system, which refers to a flash drive you added to your machine, to a directory you created. So the command would basically be this one here, right? Roughly speaking, this is how you take an existing file system that's linked to an existing device, which was added to your machine, and mount it to a directory you created. And from that moment on, you could use cd, change directory to that folder, and put information there, or read the information that's on the flash drive. And it could be, for example, from a good hard drive. So the idea here isn't for us to go deep into LVM architecture, because that's handled by a Linux team within your environment. But if that's your need, there are specific courses on this type of setup. So I suggest you look for those and dive deeper into topics like creating partitions, logical volumes, and physical volumes. Shall I continue here? I've included an analogy here where I try to explain, using a comparison with a bookstore and its sections, how this relationship works that Linux manages between the file system and its directories. So take a look at this text where I make the analogy with a bookstore. And if you didn't understand, the reading here is pretty simple, where I draw this parallel between the Linux world and the real world, right? We compare the file system and directories to a bookstore and its shelves. While continuing on with this module, another command that's also interesting, which we've already seen, is the else L command, where basically we get information about the directories. So, for example, if I go here to the root and I run the command lsl, you'll see information about directories. We know something is a directory by the letter D. The permissions, the first three characters here refer to the owner's permissions, which could be the owner of the directory or the owner of a file. The directory will be in blue and will have a letter D in front of it. So the first letters refer to the owner's permissions. So R is for read, meaning can read. Here, a dash means there is no write permission, and X is for execute, to run executable programs. The next three letters refer to users who, for example, are part of the root group, and the permissions here. Of the root group, and if there are users within the root group, the root user themselves is, right? These users will have these permissions, and the last three letters are the permissions for other users who are not root and are not in the root group as well, okay? And we can create other groups. I still plan to demonstrate this in the next lessons. How do we create other groups, right? So here I bring this summary. We still have information here about the amount of megabytes, actually the amount of bytes related to the directory or files. When it's a directory, it shows the information about blocks here. But we'll work on this later and it will become clearer. When we check the file sizes in bytes, here, these are just directories, all right. So there's also information about when it was created, right? The directory and the file, and if it was modified, the date and time of the last update will appear. So that's it for now in this lesson. In the next lesson, we'll look at other commands that are interesting. Then you, as an Oracle DBA, will get an idea of what's running. On the server and consuming physical memory, the swap area on the disk, and also CPU usage, because many times you might be experiencing performance loss in your environment, in your Oracle database. And you'll find that you might have an issue related to physical memory or a lack of it, or even high CPU usage, possibly caused by other processes. You might be complaining that Oracle is slow, but in reality, there are other processes running on the same machine as Oracle using up a lot of CPU. So how can we see that? All right.